Hello everyone. Today I'll be presenting my assignment on sequence board game as a gameplay, and especially we'll see how we can model it as a game tree, and how we can solve it by using minimax tree, alpha beta pruning, and heuristic functions. Sequence is a two-player game or team-based game on a fixed board, and each turn players plays chips based on the cards they play. Jacks have the special powers here. We have like two-eyed jacks can be placed anywhere, and while the one-eyed jacks can remove an opponent's chips. The main objective is to complete a sequence of 5 chips in a row while preventing the opponent from doing the same. Although there is a bit of randomness from card draws. And here is the rules of the games. On your turn, play a card and place your chips on the matching spots, and then we have to draw a card. Two-eye jacks are the wild cards. As I said earlier, we have like power cards, one-eye jack and the two-eye jacks. And here we have one more power cards, like corners are wild and count for both the teams. And here how it can be represented and solved. We can represent the sequence game as a game tree with two players, max for our moves and min for the opponent's moves. We can depth limited min max search to explore the opponent moves, counter moves. And at the leaf nodes, heuristic evaluates helps estimates the board strategic factoring in threats like giving the values for those opponents' plays. And here we can solve by using alpha beta pruning helps to reduce unnecessary branches and making the search more efficient. And minimax representation, and we can see the minimax representation will help the game tree representation of our moves and the opponent moves. And heuristic function, when the tree becomes too large to explore fully, we can use heuristics. Some of the key features includes one lines of 5 immediate threats with 3 or 4 in a row, overlaps and blocking opportunities. We also add weight for jack flexibility and corner control. For example, our heuristic functions might be something like h of s when times in W1 times our threads minus W2 times the opponent's threads, plus other weighted factors like overlaps and jack powers. And here we can see the alpha beta pruning. Alpha beta pruning improves the minimax by cutting off the branches that won't affect the decisions. If one branch already provided a guaranteed better outcome, we don't need to evaluate weaker ones. With a good move ordering like checking, finishing or blocking other opponent's moves. For example, here we can see a small example of our gameplay. We are considering it's a two players game, and player A has already placed 3 blue chips and in a diagonal way, and player B notices and he tries to block the by placing a chip at the 4th position. On the next turn, player A plays a one-eyed jack to remove player B's blocking chip. This allows player A to complete the sequence of 5 in a row and win. And here by winning opportunities we can calculate it by as a highest value of the heuristic functions. This demonstrates how minimax works. Max, player A tries to extend their lines, min tries to block, and special cards like jack dramatically change the state of the game. And why this is, here is the minimax tree diagram of all the possibilities of blocking and for the max and minimum player. Why this is a good project one for candidate, because this problem is a great fit for project one. like it has a clear rules and yet deep strategies, and it also we can see here such concepts end to end and minimax heuristic on alpha beta pruning. It's also scalable. Thank you.